Energy and phase changes. A phase change converts one state to another. For example, solid to liquid is known as melting, liquid to gas is known as evaporation, and solid to gas, directly from solid to gas, is sublimation. Now, here for these three processes, energy is absorbed because when a more organized state is converted to a less organized state, then what's happening, some of the intermolecular forces are broken. So, energy must be absorbed to overcome some of the attractive intermolecular forces that hold the organized solid molecule together to form the more random liquid phase. So for all these three processes, energy is required. That means all these three processes are endothermic processes. So melting, evaporation, and sublimation are endothermic. Now, here you need to learn one more term which is called heat of fusion. And what is heat of fusion? That the needed to convert amount of energy needed to convert or melt 1 gram of a substance is called heat of fusion. So if you take 1 gram of the substance and the energy required to melt that 1 gram of a substance is heat of fusion, then what will be heat of vaporization? Remember, vaporization is where you're changing liquid to gas. So that means you can say heat of vaporization will be amount of energy needed to evaporate. Melt will change to evaporate. Evaporate 1 gram of a substance is called heat of vaporization. Now, the opposite processes, uh, for example, converting liquid to solid is freezing, gas to liquid is condensation, and from the gas directly to the solid is deposition. Now, these three processes, so here if you look, you're going from less organized to more organized. So, in these processes, these are favorable processes, energy is released. And in what type of reactions energy is released? In exothermic reactions. So that means freezing, condensation, and deposition, all three are exothermic reactions. Now, these phase changes, you can also represent them in terms of heating or cooling curves. So, for example, let's say, let me draw a graph here. So, x-axis, y-axis. Y-axis is the temperature in degrees Celsius, and x-axis is heat added. So let's say we have, I'm going to put some temperatures here, minus 15 degrees Celsius, 0, 15, 100, and so on. So let's talk about the water. At minus 15 degrees Celsius, it is in the solid form, and you're adding the heat. When you add the heat, when it reaches temperature 0, then at this point it's still in the solid form, but so at negative 15 is solid, 0 is solid, and then what happens here, then this ice starts melting. We are using the heat at this point to melt the ice, and that is called heat of fusion. So heat required to change solid to liquid. Once the ice is completely melted, that means at this point we have all the liquid, and now when you are heating it, that heat will be used to increase the temperature. It's going to keep increasing. Once it reaches 100 degrees Celsius, here at this point is the liquid form. Now the heat is getting used up to change liquid to the gas. At this point, now all the water is in the gaseous form. If you still keep eating, then you end up making the superheated steam. So this is a heating curve where when you're adding how the substance is going from one phase to another, but keep in the mind that at this part heat is used to change the temperature, while at this part heat is used to change the phase. At this part heat is used to change the temperature. At this part heat is used to change the phase.
Made with Doodlecast Pro.